Hello everyone, welcome back to Step 2 Engineer channel. I'm going to share with you today is standard flange MAWP reduction. As for the details, in our pressure vessels and piping field, there will be standard flanges, ASME flanges, GIS flanges, and etc. Depending on the customer and the project's requirement, there will be many flange standards. Since we are designing ASME vessel most of the time, we will continue to explain on ASME standard flange. I have explained about how to check MAWP, minimum allowable working pressure, for standard flanges in previous videos. If you want to learn more about standard flange MAWP, please refer to this previous video. Let's continue about flanges. These flanges are used on the nozzle of pressure vessels, heat exchangers, piping connections. These flanges are used not only for attachments of another pipe lines, but also the instrument's attachment. For example, an instrument-only nozzle, like installing with safety valve, installing with pressure gauge, installing with transmitter, etc.
On the other hand, there will be inlet-outlet connection, drainage nozzle, which are connected to another pipelines. If the nozzle has a piping connection like this, it will definitely have contract and expansion due to temperature/pressure, especially temperature change. Flow coming from the piping line like liquid flow, gas flow. Because of this kind of flow vibration along the piping line, there will be loading.
All these loading distribute along the way of pipeline and finally impact to the nozzle face of the pressure vessel.
Therefore, there will be nozzle load wherever outside piping is connected. Depending on the different flange rating of 150 ham, 300 m, there are different nozzle loading at the piping connection. If there is nozzle loading, the nozzle loading coming from this piping line will impact to the nozzle. From the nozzle, there will be stress at the joint of the shell and nozzle junction. For that, we usually check local stress. We only check the stress that happens in the local area. So we will explain in a new video how to check the local stress caused by nozzle loading that happens in local area. Now, it's not about local stress. If there is nozzle loading in this flange connection, there will definitely be an effect on the gasket sitting, bolt, and gasket joint. How to consider that effect? How to make this safe, it can be seen in this video, flange MWP reduction. In standard flange, there are standard MAWP value for every rating depend on design temperature and material grade. But these standard flanges MAP value will be reduced when any of external nozzle loadings is applied on the flange. Is the reduced MAWP higher enough than the design pressure? If not, should we use another rating? For example, 150 flange rating may need to increase higher rating 300 tmer due to normal MAWP rates reduced by adding of external nozzle loading. That's what I'm talking about overall. We will continue to explain the details, relevant code, specification. In the presentation slide, I will explain detail information like which values from which clause to be used. I will continue to explain the details and document references about the flange rating in this slide. The screen that everyone is seeing now is the nozzle list in the pressure vessel. This is a simple pressure vessel. There are pound 150 flange, pound 300 flange. On the N1 30 and number 150 flange, I will continue to explain this slideshow. This is a PV Elite nozzle input window. Nozzle material SA50 LF2. We chose number 150 flange under group 1.1. The flange rating is 16.94 bars. This is a value auto-generated by PV Elite after selecting the material and rating of the nozzle. To make sure, we will double-check it with relevant group table of ASME B16.5. This is double-checking section is added for good engineering practice. If we don't do this habit, young engineers will always depend on software auto-generate value and will forget where is these reference value came from. This is group table with group 1.1, materials SA350, SA105, etc., which is the group table with the most normal carbon steel. The temperature is between 100 and 150 C. It is because design temperature of the pressure vessel is 120 degrees Celsius. But in the table that we are currently seeing, the value is 100 to 150. Therefore, we can easily calculate for 120 C by mean of linear interpolation sen. So 150-pound flange MAWP is 16.94 bars. Previous one is the value we just generated in PV Elite. The arrow you see now is the value generated from the report, and check with the table of ASME B16.5. This is how we check that these two values are the same and where we can get this value. Let's continue. Design pressure of current pressure vessel is 14 bar. Design temperature 120 degrees Celsius. In summary, according to B16.5, pound 150 flange, group 1.1, the operation temperature of SA50LF2CL1 is 120 degrees Celsius. And our flange MAWP is 16.94 bars. 16.94 bars is at the condition where MAWP is derated, has not yet been considered. It is just the flange MAWP of these materials at temperature. As I said in introduction, if there is a piping connection, there will be nozzle loading on the flange. This nozzle loading, force, and moment have not yet affected anything in this situation. Can the flange MAWP decreased in such a situation where force and moment are applied? We can see that engineers tried to calculate these decreased MAWP as per design code and specification methods. Generally, there has some potential leakage when the forces and moments of nozzle loading is applied at the flange connection. To overcome this potential leakage, we have to derate the flange MAWP as additional safety procedure. It does not mean that no leakage will not happen after MAWP derating is applied. It can only reduce the possibility of leakage. There are about 4 types of MAW reduction methods. We will explain the method that we use the most, which is the most requested by the client. It is according to UG 44B under ASME Section V Division 1. This is the screen of menu bar of one pressure vessel design on PV Elite software. Go to the Set Configuration parameter under the Tool, Nozzle Analysis option. You will see the 4 methods if you click the down arrow next to the ANSI Flange Pressure Reduction Options tab. From that, I will select ASME UG44, which will continue to be explained. The previous slide is for the procedure under the main configuration of PV Elite. It is for assigning all the nozzles in the vessel nozzle loading will be derated according to UG44B. In addition, we still need to assign again UG44B on individual nozzle on the vessel. This is the option window of a nozzle. SA350 LF2 pound 150 group 1.1 is used. Tick the box derate flange if externally loaded. It describes clearly to derate the flange MAWP if there is external loading. So tick this option. This is the setting or comment that this nozzle will be designed under flange MAWP derate. This is material and rating, configuration of nozzle. Since the nozzle is externally loaded, we must add external loading, so we will go to the local stress tab. Add nozzle loading value that provided by the client or the client's specification or sometime API standard. I'll explain in separate video how to get nozzle loading, load value from which table, specification, API code, and etc. Choose WRC 101. Add force and moment. Add radial force, circumferential force, shear force, and moment. When the nozzle loading is completed for 30-inch nozzle 150 pounds, we can clearly see that the flange rating is reduced to 13.401 bars. This value is less than the required design pressure of 14 bars. If so, we can clearly see that current flange rating pound 150 is not suitable anymore after derating. 150 pounds is not enough. So what are we going to do next? This is how we key in and how we calculate in PV Elite. This is the MAP result on report that is generate out flange, FYI. The result is 13.4 bars, less than the design pressure of 14 bars. There is one important point where the nozzle loading is added. The axial force value must be the tension minus value. The axial force p-value must be a negative value, as I have shown in the snap. The software will enter this negative value into the derating formula. If you wrongly add 45,000 instead of minus 45,000, this opposite direction axial value will be used in formula. This result will not be actuate, and wrong MAWP value will get. This is one of the important point. The current situation is not enough, so what we'll do next? Reopen the option of the corresponding nozzle. Here, I change the flange rating from 150 pounds to 300 pounds. When 300 pounds is selected and the flange MAWP derate is used, the flange's rated MAP goes up to 38.252 bars. Now it is higher than our required design pressure, 14 bars. Then it is safe to use. This is the explanation of the UG44B result from the report as shown in the previous slide. According to the formula, the value is 38.252 bars, which is safe to use with a design pressure of 14 bars. As conclusion, there are flange with external nozzle loading. UG44B is needed to consider for reduction of original flange ring MAWP due to external nozzle loading. Therefore, Original flange MAWP 19 something bar will become 13 something bar, and it is lower than required design pressure. On this situation, we need to increase flange pound rating. At that time, we will have higher MAWP as per standard, and it will recheck one more round for derating calculating process. From that, we will get final MAWP, which is higher than design pressure. Now, one question come out. If we increase 150 to 300 pound rating, should we recheck with 115 harp nozzle loading or 300 harp nozzle loading from specification? The answer is definitely 115 harp nozzle loading to be used for rechecking. We still have to use previous nozzle loading value of lower flange rating, because the whole pipeline will use 115 harp rating flanges except from that specific vessel nozzle flange. So 150 SHUP rating nozzle loading value shall be used for all flanges in this line. Therefore, 150 SNOP rating nozzle loading value can be used even though we increase to 300 pound rating flange due to derating result. Thanks for watching. If you have any question, please raise the question in the comment box.